The universe looks wide open and endless, but it is ruled by a strict boundary. No matter how powerful the engine or how advanced the technology, there is a speed that cannot be crossed. This limit is not set by machines or materials. It is built into reality itself. Light moves through empty space at a fixed and unchanging speed. This speed is the same everywhere, in every direction, and for every observer. It does not matter how fast you are moving or where you measure it from. Light always wins the race in exactly the same way. This is not simply because light is fast. It is because this speed defines how the universe is allowed to work. It is the maximum rate at which information, cause and effect, and physical influence can travel. Everything with mass is constrained by this rule. At first, this feels wrong. In everyday life, more power always means more speed. A stronger engine pushes harder. A faster car goes faster. This logic works perfectly at human scales, but as speed increases toward the cosmic limit, this familiar rule begins to fail. In the early 20th century, Albert Einstein realized something disturbing. If the speed of light is truly constant, then space and time cannot behave the way people assumed. They cannot be rigid and absolute. They must bend to preserve this limit. Space and time are not separate arenas where events unfold. They are woven together into a single structure called space-time. Every motion is a movement through this combined fabric. Every object follows a path through space-time, whether it is standing still or racing across the cosmos. Here is the first strange truth. Even when you feel motionless, you are already moving. You are traveling through space-time at the speed of light right now. The reason you do not notice is because your motion is almost entirely through time rather than through space. Each second that passes is not just a tick of a clock, it is movement. You are rushing into the future at the maximum possible rate. 1 second per second is not slow. It is the fastest motion through time that exists. When you begin to move through space, something must change. You cannot exceed the total space-time speed limit. So if more of your motion is redirected into space, less remains available for motion through time. This trade is not optional. It is automatic and unavoidable. Move faster through space, and time itself slows down for you. This effect is called time dilation, and it is one of the most tested ideas in all of physics. Scientists have measured this effect with extraordinary precision. Atomic clocks placed on airplanes tick slightly slower than identical clocks left on the ground. The difference is tiny, but it is real and repeatable. The same effect appears in space. Satellites orbiting Earth experience time at a different rate than clocks on the surface. Without correcting for this difference, navigation systems would fail within minutes. These effects are small at everyday speeds, but they grow dramatically as velocity increases. At extreme speeds, time itself stretches and distorts in ways that defy common sense. Einstein formalized this behavior using a single mathematical factor that governs how space-time responds to motion. This factor remains calm and quiet at low speeds, but as velocity climbs closer to the speed of light, it begins to surge. At modest speeds, the factor is almost equal to 1. Nothing seems strange. Classical physics still works. But as speed increases, the factor grows larger and larger. This growth is not linear. Each step closer to light speed causes a larger change than the step before. What begins as a gentle slope turns into a steep rise. Time slows, lengths contract, motion becomes harder. Reality itself resists acceleration more strongly with every increase in speed. This resistance is not caused by friction or mechanical limits. It comes from space-time itself. The universe enforces its speed limit by reshaping how motion works. The closer you get to the limit, the more extreme the consequences become. Every gain in speed demands a greater sacrifice from time. This is only the beginning of the problem, because time is not the only thing affected. Something far more dangerous begins to grow alongside it. Momentum does not behave the way intuition expects. Energy does not translate cleanly into speed anymore. Instead, motion becomes trapped behind an invisible wall. To understand why nothing can ever reach the speed of light, we must follow this path all the way to its breaking point. And what waits there is not a technical obstacle, but a fundamental refusal written into the structure of the universe. To see where this refusal comes from, you have to look at how motion really works when speeds become extreme. At low velocities, momentum behaves politely. It is simply mass multiplied by speed. Push harder and objects respond in predictable ways. This simplicity collapses as velocity rises. Einstein showed that momentum is not just mass times velocity. It is multiplied by a factor that grows as speed approaches the cosmic limit. This single change rewrites everything about acceleration. At ordinary speeds, the factor is so close to 1 that it can be ignored. A car on a highway behaves exactly as Newton predicted, but as velocity climbs, this factor stops being negligible. At half the speed of light, momentum is already significantly higher than classical physics expects. The object resists acceleration more strongly, even though its mass has not changed at all. At 90% of light speed, this resistance more than doubles. Pushing the object requires more than twice the force Newton's laws would predict. Nothing about the object looks different, but it behaves as if it were heavier. This is not an illusion, and it is not a measurement trick. It is how space-time responds to motion. The faster an object moves, the more momentum it accumulates beyond classical expectations. As speed increases further, the effect accelerates. At 99% of light speed, momentum is multiplied many times over. Each additional increase in velocity requires far more force than the last. This creates a vicious cycle. More force increases speed. Higher speed increases momentum. Higher momentum demands even more force. Each step feeds back into the next. Eventually, the process runs away. The required force grows faster than any achievable source of energy. No engine, no matter how powerful, can keep up with the demand. Mathematically, this resistance approaches infinity. As velocity nears the speed of light, momentum grows without bound. To change infinite momentum by any amount would require infinite force. Infinite force is not just impractical, it is forbidden. The laws of physics do not allow infinite quantities to exist in reality. This is how the universe enforces its limit. It does not suddenly stop you. It simply makes further acceleration harder and harder until it becomes impossible. Particle accelerators demonstrate this every day. Protons are pushed with enormous energy inside circular tunnels. They reach astonishing speeds, incredibly close to light speed. Yet no matter how much energy is added, they never reach the limit. Each additional fraction of a percent demands more energy than all the previous acceleration combined. The particles do not break. The machines do not fail. Reality itself resists the push. Measurements confirm this behavior exactly. The momentum of these particles increases precisely as Einstein's equations predict. The closer they get to light speed, the less responsive they become. This is not a technological failure. It is not a lack of engineering skill. It is a fundamental feature of space-time. Even if you imagine a perfect engine with no losses, no friction, and unlimited durability, it would still fail. The demand for force would climb faster than any finite source could supply. Momentum alone already blocks the path. But it is only part of the trap. Something even more devastating grows alongside it. Energy does not simply turn into speed at high velocities. It transforms into resistance. The universe redirects your effort away from motion and into something far more costly. This is where the problem becomes absolute. Not difficult, not impractical, impossible. To understand why, you must look at the deepest relationship between mass and energy, a relationship that turns motion itself into a nightmare as the speed of light draws near. Energy and mass are not separate currencies of the universe. They are two expressions of the same substance. This was the most unsettling message hidden inside Einstein's equations. A small amount of mass contains an enormous amount of energy. This is not philosophy or metaphor. It is a precise, quantitative relationship that governs stars, reactors, and explosions. When matter converts into energy, the release is staggering. The light of stars, the heat of the sun, and the force of nuclear weapons all come from this conversion. Tiny losses of mass produce immense power. But the equation works in reverse as well. Energy can become mass. This happens routinely in high-energy particle collisions, where pure energy condenses into new particles. This symmetry destroys any hope of reaching the ultimate speed. Because when you accelerate an object, you are not just increasing its speed, you are adding energy to it. At low velocities, this energy mostly becomes motion. The object simply moves faster. The relationship feels intuitive and forgiving. As speed increases, that relationship begins to change. Less of the added energy turns into velocity. More of it becomes resistance to acceleration. The object does not gain mass in the ordinary sense. If you stop it and place it on a scale, it weighs the same as before, but its inertia grows. It fights every attempt to push it faster. This resistance is real and measurable. It is not a trick of perspective. It is how energy expresses itself at extreme speeds. As velocity climbs closer to the cosmic limit, the required energy rises faster than the speed itself. Each increase in velocity demands disproportionately more energy than the last. At moderate fractions of light speed, the energy involved already rivals the output of the largest weapons humanity has ever built. And this is for objects that weigh almost nothing. The curve is unforgiving. Doubling the speed does not double the energy, it multiplies it many times over. As the limit approaches, the energy requirement explodes. The equation stops behaving politely and begins to diverge wildly. At the boundary itself, the mathematics breaks. The energy required becomes infinite. Not large, not astronomical, infinite. This is not a failure of calculation. It is a warning encoded into the structure of the equations. The universe refuses to assign a finite energy cost to reaching light speed. An infinite requirement cannot be met. No fuel supply can satisfy it. No engine can deliver it. No clever design can bypass it. Even a single elementary particle would demand more energy than exists anywhere in the observable universe. And then it would demand more beyond that. This is not an engineering challenge waiting for future technology. It is a hard prohibition enforced by the deepest laws of nature. Every attempt to push matter closer to the limit feeds the same outcome. Energy piles up, inertia increases, and progress slows to a crawl. You can keep adding energy forever. You will keep getting closer, but the destination never arrives. The closer you get, the more violently the universe pushes back, not through explosions or barriers, but through relentless mathematical resistance. This is why no experiment has ever crossed the threshold. Not once, not accidentally, not briefly. Energy itself becomes the jailer. Motion is locked behind an infinite cost that cannot be paid. And this still is not the final strangeness, because beneath the energy barrier lies an even deeper rule, one that reveals you are never truly standing still to begin with. The deepest rule is not about engines or particles, it is about motion itself. Not motion through space, but motion through space-time. Every object in the universe moves through space-time at exactly the same total speed. That speed is the speed of light. There are no exceptions. This sounds impossible at first. You feel stationary. The room around you is still. Nothing about your experience suggests that you are moving at a cosmic limit. But the motion is real. It is simply directed almost entirely through time rather than through space. Space-time has 4 dimensions. 3 are spatial, 1 is temporal. Motion can be distributed among them, but the total always remains fixed. When you're at rest in space, All of your motion is directed through time. You move 1 second into the future every second. That is maximum speed through the time dimension. Begin to move through space and the balance shifts. Some of your space-time motion is redirected from time into space. Walk across a room and the effect is negligible. A microscopic fraction of your motion leaves time and enters space. Your clock slows by an amount too small to notice. Board an aircraft and the shift becomes measurable. Atomic clocks reveal that time on board passes more slowly than time on the ground. Orbit Earth and the effect grows stronger. Satellites experience time differently, enough that engineers must correct for it continuously. As speed increases further, the redistribution becomes dramatic. At half the speed of light, half of your space-time motion is through space. The other half remains in time. Your clock now runs at half the rate of a stationary observer. For every hour you experience, 2 hours pass elsewhere. Push closer to the limit, and nearly all motion shifts into space. Time slows to a crawl. At 99% of light speed, only a tiny fraction of motion remains for time. Your clock barely advances, while the outside universe races ahead. This is not subjective illusion. Your body functions normally, your heart beats normally, your thoughts feel normal. The difference appears when paths through space-time are compared. Two travelers who take different routes do not agree on how much time has passed. This is why time is not universal. There is no master clock ticking the same for everyone. Each object carries its own proper time. At the limit itself, something extreme occurs. All motion would be directed into space. None would remain for time. From that perspective, time would stop completely. No aging, no change, no passage of moments. This is why light does not experience time. A photon emitted and absorbed across the universe completes its journey in zero time from its own perspective. Objects with mass can never reach this state. They can approach it, but never complete the transfer. There is always some residual motion through time, always some ticking, always some change. Stopping time entirely would require infinite energy. It would require shifting 100% of motion into space, which is forbidden. The universe enforces this balance absolutely. You may trade space for time or time for space, but the total can never exceed the limit. Light speed is not just a barrier ahead of you. It is the speed you are already moving through reality right now. This realization leads to consequences far stranger than speed limits. Because if motion reshapes time, then different journeys create different futures. And that means velocity itself becomes a machine for traveling through time. Once motion becomes a tool for reshaping time, the universe reveals a deep asymmetry. Two travelers who part ways and reunite will not agree on how much time has passed. This is not a paradox or a trick. It is a direct consequence of taking different paths through space-time. Imagine two identical clocks synchronized perfectly. One remains at rest, the other moves at high speed and later returns. When they meet again, the moving clock shows less elapsed time. This difference is not caused by acceleration or mechanical stress. It is caused by the geometry of space-time itself. The moving clock followed a shorter path through time. It spent more of its motion in space and less in time. This effect has been measured repeatedly. Aircraft carrying atomic clocks return with times that differ from clocks left behind. The disagreement matches predictions exactly. Even elementary particles obey this rule. Muons created high in Earth's atmosphere should decay quickly, yet they survive long enough to reach the surface. They do not cheat death. Time runs slower for them because they are moving at extreme speed. Their internal clocks tick more slowly relative to Earth. Technology depends on this behavior. Navigation systems rely on clocks that experience time at different rates due to both motion and gravity. Engineers do not debate whether relativity matters. They program it directly into the hardware. Without these corrections, positioning errors would grow rapidly. Velocity creates one-way travel into the future. Move fast enough and you age more slowly than those left behind. From your perspective, nothing feels strange. You eat, sleep, think, and age normally. But when you return, the world has moved on. Years or decades may have passed while you experienced far less. This is not science fiction. It is a measured, verified effect of motion. The faster you travel, the greater the difference becomes. At modest fractions of light speed, the effect is small. At extreme fractions, it becomes overwhelming. Near the limit, centuries can pass elsewhere, while only years pass for you. This is not because time speeds up outside your ship. It is because your path through space-time allocates less motion to time. Time dilation is not a side effect. It is the price paid for motion through space. The exchange rate is set by the same factor that blocks light speed. The faster you go, the more time you give up. This trade cannot be renegotiated. It is woven into the structure of space-time. No clever engineering can avoid it. No alternative fuel can bypass it. To move faster is to age slower. To approach the ultimate speed is to surrender almost all motion through time. And this surrender is what finally seals the barrier, because reaching light speed would require giving up time entirely. A massive object cannot do this. It must experience time. It must change. It must have a sequence of moments. Light speed demands the impossible. A traveler with mass who no longer moves through time. This is why the barrier holds. Not because the universe lacks power, but because reality refuses to erase time for objects that possess mass. The limit is not just about how fast you can go. It is about whether you are allowed to exist as a changing thing at all. This refusal reveals something unsettling about existence. Change itself depends on time. Without time, nothing can happen. No motion, no thought, no decay, no cause leading to effect. An object with mass cannot exist without time passing for it. Its particles vibrate, its internal processes unfold. Its very identity depends on sequences of events. To reach light speed would mean eliminating that sequence. It would mean arriving at a state where nothing inside the object can evolve. This is why the universe draws the line where it does. It is not protecting light, it is protecting causality. Cause must come before effect. Information must have an order. Events must unfold in sequence. Light speed is the maximum rate at which this order can be preserved. Exceeding it would break the chain. Effects could appear before causes. Information could arrive before it was sent. The equations do not merely discourage this, they forbid it by making the cost infinite. As speed increases, clocks slow. As clocks slow, the ability to change weakens. At the limit, change would vanish entirely. Photons escape this fate because they have no rest mass. They do not require internal processes unfolding in time the way massive objects do. A photon does not age. It does not experience before and after. It simply exists along its path. Massive objects cannot do this. They are anchored to time by their mass. This anchoring shows up everywhere. In particle accelerators, unstable particles live longer when they move fast. Their decay processes slow down. The faster they go, the more stubbornly time clings to them, refusing to disappear completely. Even at extreme energies, some motion through time remains. The clock never fully stops. This residual ticking is what keeps the object massive. It is what prevents the final step to light speed. The barrier is not a wall in space, it is a wall in time. No matter how much energy you pour in, you cannot erase that last trace of temporal motion. The equations push back harder and harder as you try. Momentum explodes, energy diverges, acceleration grinds towards zero. The universe is not being cruel, it is being consistent. Everything that has mass must have time. Everything that has time cannot move entirely through space. Light alone lives on the edge, where time disappears and distance collapses. For everything else, the trade is fixed. Space gained always costs time. This is why reaching light speed is not just unlikely, it is logically incompatible with being a massive object. The closer you get, the more reality strips away what makes motion meaningful. At the edge, there is no remaining structure for matter to occupy. And this is only half of the story. Because if time itself bends with motion, then space cannot remain untouched. The same rule that slows clocks also reshapes distances, twisting geometry in ways that feel equally impossible. When time bends, space must bend with it. The two are inseparable parts of the same structure. You cannot distort one without reshaping the other. As an object moves faster, not only does its clock slow down, its length along the direction of motion shrinks. This is not an optical illusion, it is a real physical contraction. To an observer at rest, a fast-moving object is compressed in the direction it travels. The faster it moves, the shorter it becomes. At everyday speeds, the effect is far too small to notice. A car driving down a road does not visibly shrink. The contraction is smaller than atoms. But as speed approaches the cosmic limit, the effect becomes dramatic. At 90% of light speed, an object is less than half its original length. At 99%, it is compressed to a fraction that defies intuition. The faster it goes, the more space itself seems to collapse. From the traveler's perspective, nothing appears wrong. The ship feels normal, the walls are solid, the distance between front and back is unchanged. Instead, it is the outside universe that appears distorted. Distances along the direction of motion look shorter. Entire regions of space seem compressed ahead. This symmetry is crucial. There is no privileged perspective. Each observer sees the other as distorted. This mutual distortion is not contradiction. It is geometry. Different paths through space-time slice reality in different ways. Length contraction is not an extra effect. It is required to preserve the constant speed of light for all observers. If space did not contract, light speed would not remain the same in all frames. The universe adjusts its geometry to protect that rule. As velocity increases, both time and space are sacrificed. Clocks slow, lengths shrink. Reality rearranges itself to prevent the limit from being broken. At the boundary, something extreme would occur. The length of a massive object in the direction of motion would collapse towards zero. This is not survivable. Not physically, not logically. There would be no internal structure left to define the object. Once again, the equations intervene before this can happen. Infinite energy appears long before space collapses completely. The universe refuses to let matter reach a state where its spatial extent vanishes. This contraction also explains why the speed limit is so absolute. Pushing faster does not just demand energy, it deforms the object itself. Space resists, time resists, geometry resists. All three combine into a unified defense against exceeding the limit. This is why motion at extreme speeds feels increasingly unnatural. You are not just moving through space, you are fighting the shape of space-time itself. Every attempt to accelerate further deepens the distortion. Every gain costs more than the last. At some point, no meaningful motion remains to be gained, only deformation. Light occupies the boundary where time stops and length collapses to zero. That boundary belongs to massless entities alone. For everything else, the approach becomes a narrowing tunnel that never quite ends. You can rush toward it forever, but it never opens into passage. And this geometric resistance is still not the final obstacle, because behind it lies the deepest consequence of the limit. At extreme speeds, the very idea of simultaneity begins to fall apart. As space and time distort, something even more unsettling happens. Events that once seemed simultaneous no longer agree across observers. Two flashes of light that occur at the same moment for one observer may not occur at the same moment for another. This is not confusion or delay. It is a fundamental disagreement about time itself. Simultaneity is not universal. There is no single present moment shared by the entire universe. At low speeds, this difference is too small to notice. Everyday life hides it completely. The world appears synchronized. But as velocity increases, the disagreement grows. Observers moving relative to each other slice space-time differently, dividing events into past, present, and future in incompatible ways. This is not philosophical, it is mathematical and experimentally verified. The speed of light forces this outcome. If light speed must be constant for everyone, then time ordering cannot be absolute. Different observers cannot agree on which distant events happen at the same time, because information cannot travel faster than light to enforce agreement. As you approach extreme speeds, this breakdown becomes unavoidable. The faster you move, the more your definition of now tilts relative to others. Events that are simultaneous for you may lie in the past or future for someone else. This does not create paradoxes, because no information can cross the light speed boundary to exploit the disagreement. Causality remains safe. Cause still precedes effect within every local frame, but the cost is the loss of a universal present. Reality fragments into many equally valid timelines. This fragmentation intensifies near the limit. The concept of global time dissolves, reaching light speed would shatter simultaneity completely. There would be no meaningful way to define a present moment across space. Once again, the equations intervene before this collapse occurs. Infinite energy appears before simultaneity can be destroyed entirely. The universe blocks the final step, not only to preserve matter, but to preserve coherent ordering of events. Without this ordering, the structure of physics would unravel. Relativity does not allow reality to tear itself apart. It builds barriers where coherence would otherwise fail. This is why the speed limit is more than a number. It is a safeguard for the consistency of space-time. Every effect described so far is not an accident. They are all linked responses to the same constraint. Time dilation, length contraction, energy divergence, momentum explosion, and the loss of simultaneity all point to the same conclusion. Light speed is the boundary between ordered reality and mathematical breakdown. Crossing it would not unlock new freedom. It would erase the framework that allows freedom to exist at all. The universe does not permit that erasure. Instead, it lets you approach the boundary endlessly, learning its rules more clearly with every step. And with each step, it reveals that the limit is not an obstacle placed in your path. It is the shape of the path itself. Once the path itself defines the limit, the idea of exceeding it loses meaning. Faster than light is not forbidden by force, but by geometry. The structure of space-time separates all motion into two categories: paths that remain below the limit and paths that belong only to light. Massive objects follow one kind of path. Light follows another. There is no continuous bridge between them. Trying to cross from one to the other is like trying to rotate time into space completely. The mathematics refuses to allow it. This separation explains why nothing with mass can ever behave like light. The two occupy different regions of space-time. For massive objects, time always flows forward. Their paths are constrained to move from past to future. Light follows a path where time does not advance. Distance collapses. Cause and effect merge at the boundary. These are not choices, they are consequences of the space-time metric itself. As long as an object has mass, its path must include motion through time. This anchors it firmly below the limit. Removing that last trace of time would require removing mass entirely. This is why particles with zero mass move at light speed. They have no option to do otherwise. Everything else is locked into a slower path. This division preserves causality. It prevents signals from outrunning light and rearranging cause and effect. If faster than light travel were allowed, effects could precede causes in some frames. Paradoxes would arise instantly. The geometry prevents this by forbidding the transition. Even theoretical constructs that appear to exceed light speed do not violate this rule. They either involve no transfer of information or rely on space-time itself doing the moving. Nothing locally outruns the limit. The boundary holds everywhere. In laboratories, in galaxies, and across cosmic distances. This universality is crucial. It means the rules do not depend on location or era. The same limit governed the early universe and governs it now. It will govern every future experiment and every future civilization. No discovery will remove it because it is not an added rule. It is the foundation. The equations do not say you cannot go faster. They say there is no physical meaning to doing so. Beyond the limit, quantities turn imaginary. Time and space exchange roles in nonsensical ways. Physics does not describe that region because it cannot exist for massive matter. The barrier is not something to overcome. It is something to understand. Once understood, it reshapes how motion, time, and existence are viewed. The universe is not a stage where anything is possible with enough power. It is a structured system where possibility itself has boundaries, and the speed of light marks the edge of those boundaries. Everything allowed lies within. Everything forbidden lies beyond. This realization does not close the story. It opens a deeper question. If the limit is so fundamental, why does the universe choose this value at all? The value of the limit is not arbitrary. It is woven into the constants that define how reality behaves. The speed of light connects space and time through a fixed conversion rate. It tells the universe how many units of space equal 1 unit of time. Change that number, and the structure of space-time itself would change. This speed appears everywhere in physics, not just in light. It governs electromagnetism, causality, and the geometry of the universe. It sets the scale at which space and time become interchangeable. Long before Einstein, equations already hinted at this constant. Maxwell's equations predicted waves that moved at this exact speed. Einstein realized that this was not about light specifically. It was about a universal property of space-time. Light merely obeys the rule. It does not create it. The limit acts as a conversion factor. It translates temporal separation into spatial distance. 1 second of time corresponds to a fixed distance in space. This relationship allows space-time to behave as a unified whole. Without it, physics would fracture into disconnected rules. The constancy of the limit ensures that all observers, no matter how they move, agree on the same causal structure. They may disagree on time intervals and distances, but they agree on what can influence what. This shared structure keeps reality consistent. If the limit were higher or lower, everything would change. Atoms, stars, and chemistry would behave differently. The universe we know is built around this value. It is not tuned for convenience. It is simply how space-time is defined. The limit also explains why nothing special happens as you approach it locally. There is no sudden shock or barrier. Instead, effects accumulate gradually, becoming extreme only at the edge. This smoothness hides the limit at low speeds and reveals it only when pushed. It allows classical physics to emerge naturally from relativistic laws. Newton's equations are not wrong. They are approximations valid far from the boundary. As speeds increase, the deeper structure asserts itself. The universe does not snap, it curves. And this curvature is what protects the limit from violation. Every attempt to exceed it is redirected into distortion rather than speed. The value of the limit sets the stiffness of space-time. It determines how strongly time slows, how sharply space contracts, and how fast energy diverges. It is the constant that defines how resistant reality is to being bent. Understanding this does not grant a way around the limit. It explains why there is no around. The speed of light is not a challenge to be overcome. It is the conversion rate that makes the universe coherent. And within that coherence lies every possibility that can exist. Once the structure is understood, the remaining mystery is not why the limit cannot be crossed, but why motion feels so normal far below it. At human scales, space-time behaves gently. Time flows evenly. Space feels rigid. Cause and effect appear absolute. This calm is deceptive. It is not because the rules are different. It is because the distortions are too small to notice. At low speeds, the exchange between space and time is microscopic. The loss of time is measured in fractions so tiny they vanish into noise. This is why everyday intuition works. It is why Newtonian physics feels correct. The deeper rules do not disappear. They simply whisper instead of shout. As long as velocities remain small compared to the limit, space-time barely resists. Momentum grows linearly. Energy translates cleanly into speed. Only when motion begins to claim a noticeable share of the total space-time velocity do the distortions reveal themselves. This explains why the limit hides so well. Nature does not announce it. It waits patiently until you approach. Civilizations can rise, build machines, explore planets, and never feel its presence directly. Only when pushing toward extremes does the universe reveal its true rigidity. Particle accelerators were the first places where the whisper became audible. Tiny particles forced to move near the limit exposed the hidden structure of motion. Time slowed, energy exploded, momentum refused to behave. Nothing unexpected happened. The equations had already predicted everything. What surprised humanity was not that the barrier existed, but that it was so perfectly enforced. Every experiment confirmed the same pattern: no loopholes, no cracks. The more precisely the limit was tested, the more absolute it became. This consistency revealed something profound. The universe is not patched together from rules. It is built from a single, coherent framework. The speed limit is not a feature layered on top of physics. It is a consequence of how space-time is constructed. Remove it and the framework collapses. This is why no new discovery has weakened it. Every advance has strengthened it. Quantum theory did not break it. Field theory did not bend it. Even attempts to unify gravity with quantum mechanics leave the limit untouched. It appears at every scale, from subatomic interactions to cosmic expansion. Light speed governs how galaxies evolve, how stars communicate internally, how particles interact. It sets horizons beyond which information cannot reach us. It defines the observable universe itself. Regions beyond a certain distance are forever hidden, not because of darkness, but because signals cannot arrive in time. The universe has edges, not of space, but of causality. This is another consequence of the limit. The cosmos is finite, not necessarily in size, but in what can be known. Every observation is constrained by the same rule. This makes the limit more than a speed. It is a boundary of knowledge. Nothing can influence you faster than light. Nothing can inform you instantly. This delay shapes everything: evolution, communication, structure. Without it, the universe would behave radically differently. Instant influence would erase locality. Everything would affect everything else at once. Complex structures would struggle to exist. The limit protects separation. It allows systems to form and persist. Stars can burn steadily because energy does not escape instantly. Atoms can exist because forces propagate at finite speed. Life depends on this delay. The same rule that blocks faster than light travel makes stable reality possible. What feels like a restriction is actually a requirement. The universe trades unlimited speed for coherence. It trades instant access for structure. Seen this way, the limit is not an obstacle placed in front of progress. It is the reason progress can occur at all. And this perspective changes the question entirely. Instead of asking how to break the limit, the deeper question becomes: what would reality look like if the limit did not exist? And the answer is unsettling. Imagine a universe without this limit. Signals would travel instantly, cause and effect would blur together. Events could influence one another with no delay, regardless of distance. The concept of here and there would lose meaning. Locality would collapse. Everything would be connected to everything else at once. In such a universe, structure would struggle to exist. Stars could not form stable cores. Energy would escape instantly. Atoms would not hold together in the same way. Forces would act without delay, destabilizing balance. Life would face impossible conditions. Biological processes rely on timing, feedback, and separation. Remove the limit, and the universe becomes chaotic, not more free. The speed limit is what allows complexity to emerge. It creates pockets of isolation where systems can develop independently. It gives time for processes to unfold. It gives cause the chance to precede effect. Without it, reality would be a single, undifferentiated event. The universe we observe is shaped by delays. Light takes time to travel. Information spreads gradually. This slowness is what allows patterns to form. Galaxies rotate. Stars burn for billions of years. Planets cool. Chemistry proceeds step by step. The limit stretches processes across time, making evolution possible. Remove it, and everything happens at once. There would be no history, no sequence, no narrative. The past would bleed into the future without distinction. Physics would lose its predictive power. Equations rely on ordering. Inputs lead to outputs. Without a speed limit, this ordering dissolves. Even mathematics would struggle to describe such a world. The universe enforces the limit to preserve meaning. Distance must matter. Time must matter. Without them, reality becomes undefined. This is why the limit appears everywhere, not just in motion. It governs communication, interaction, and change. It is the silent rule that keeps the universe from collapsing into simultaneity. The deeper one looks, the clearer this becomes. The limit is not a constraint imposed from outside. It is the condition for existence inside. This reframes the question of impossibility. Reaching light speed is forbidden, not because it is dangerous. It is forbidden because it would undo the very framework that makes danger, safety, and action meaningful. Crossing the limit would not be traveling faster. It would be erasing the concept of travel. The universe protects itself by refusing that erasure. This protection is not absolute in the sense of blocking approach. You can move closer and closer, exploring the edge, but the final step is denied. And this denial is gentle. No alarms, no explosions, just infinite cost. The barrier is elegant, not violent. It preserves structure by making violation unattainable rather than destructive. Every physical law involved aligns toward this outcome. Momentum diverges, energy diverges, time slows, space contracts, simultaneity dissolves. All effects converge on the same refusal. This convergence is not coincidence. It is the signature of a deep symmetry. The universe chooses coherence over unlimited speed, and in doing so, it reveals that limits are not always weaknesses. Sometimes they are the reason anything exists at all. This is the quiet conclusion hidden inside the equations. The speed of light is not the fastest thing. It is the rule that allows anything to happen in sequence. And that rule shapes everything we experience. But there is still one final twist. Because while nothing can cross the limit, the universe itself may appear to do something even stranger. On the largest scales, the universe seems to challenge its own rule. Distant galaxies appear to recede faster than light. This is not illusion, and it is not a violation. The motion involved is not through space, but of space itself. As the universe expands, distances between far regions grow. When those distances are large enough, the rate of increase can exceed the limit. No object locally outruns light. No signal is sent faster than allowed. The expansion stretches space rather than pushing matter through it. This distinction preserves the rule while allowing cosmic behavior that looks contradictory at first glance. The limit applies to motion within space-time, not to the evolution of space-time itself. This reveals an important subtlety. The speed limit governs local physics. It does not constrain how the universe as a whole changes shape. This is why distant galaxies can disappear beyond our observable horizon. Their light will never reach us, not because they move too fast, but because space between us grows too quickly. The horizon is not a wall, it is a boundary of causality. Beyond it, events can happen that will never affect us. This does not break causality, it defines it. The observable universe is a bubble carved by the limit and by cosmic expansion. Its size is not determined by how big the universe is, but by how long light has had to travel. This means there may be infinite regions forever unreachable. Not because of distance alone, but because of time and expansion combined. Once again, the limit shapes knowledge. It determines what can be known and what will remain forever hidden. Even with perfect technology, some answers cannot be obtained. This is not a failure of engineering. It is a property of space-time. The universe contains truths that are causally disconnected from us. They exist, but they cannot be observed. This introduces a new kind of humility. Reality is larger than what any observer can access. The limit enforces this separation gently but absolutely. Expansion does not weaken the rule, it complements it. Together, they define the cosmic stage. Local interactions obey the speed limit. Global structure evolves according to gravity and expansion. The two are consistent parts of the same framework. This balance allows a universe that is dynamic yet orderly. Galaxies form, move apart, and evolve without breaking causality. The same rule that governs particles also governs the cosmos. This unity is not obvious, it had to be discovered. It shows that the speed limit is not just about light beams or rockets. It is about how information, influence, and existence propagate at every scale. Even the growth of the universe respects it in its own way. The appearance of faster-than-light expansion is not a loophole. It is a reminder that motion and geometry are not the same thing. Space can stretch without anything traveling through it. This stretching reshapes horizons and futures. Some galaxies are already beyond reach forever. Their light will never arrive. Not because it is too slow, but because the universe itself carries it away. This realization reframes distance itself. Distance is not fixed, it evolves. And the limit interacts with that evolution in subtle ways. The universe is not static with a speed limit painted on top. It is dynamic, expanding, and constrained in a deeply integrated manner. The speed of light governs motion, expansion governs separation. Together, they define the ultimate map of what is possible. But this cosmic picture raises another question. If expansion can outrun light in this sense, what does that say about the future of the universe itself? The future of the universe is written in the tension between expansion and the speed limit. As space continues to stretch, more regions cross beyond our horizon. Galaxies that are visible today will slowly fade, their light redshifted until it disappears. Over vast timescales, the night sky will grow emptier. Not because stars die, but because information can no longer reach us. Civilizations in the far future may see only their local galaxy. The rest of the cosmos will be hidden, not destroyed. This isolation is a direct consequence of the limit combined with expansion. The universe does not end abruptly, it thins. Connections are not severed by catastrophe, but by distance growing faster than light can cross. Eventually, even clusters of galaxies become isolated islands. Each region evolves almost alone. This raises a strange thought. Different parts of the universe may experience radically different futures. What happens beyond our horizon still occurs, but without influence or awareness. The universe becomes a collection of causally disconnected domains. This fragmentation is not chaos, it is ordered separation. The same rule that once allowed structure to form now limits how long that structure can remain connected. The limit is not just a rule of motion, it is a rule of memory. Only events within the horizon can become part of our history. Everything else is erased from potential knowledge. This does not mean it is meaningless, it simply means it belongs to a different causal story. In this sense, the universe is not one narrative, but many. Each observer carries their own version, bounded by the limit. This perspective alters how the future is imagined. The fate of the universe is not a single ending, but countless isolated evolutions. Some regions may continue forming stars, others may grow cold and dark. All obey the same local rules, yet remain forever separated. The speed limit ensures that no signal can reunite these regions. No future technology can bridge that gap. The separation is permanent. This permanence is not imposed by decay or destruction, it is imposed by geometry. The shape of space-time decides what futures can interact. Expansion stretches that shape relentlessly. The limit ensures the stretching eventually wins. This leads to a universe that becomes quieter, not emptier. Processes still happen locally. Stars burn, planets orbit, time flows. But the shared cosmic context fades. The universe loses its chorus and becomes a collection of solo performances. This outcome is not tragic in a dramatic sense. It is neutral, almost gentle. The laws that allowed complexity also allow isolation. They do not favor connection forever. They allow it for a time. This time is long by human standards, but it is finite. Understanding this gives the speed limit a new role. It is not only a barrier to motion, it is a timer on cosmic togetherness. It defines how long the universe can remain a shared experience. Once that time passes, separation becomes permanent. And still, the rules remain unchanged. Local physics continues as always. The same limit applies in every isolated region. The universe does not break its rules as it ages. It follows them to their ultimate consequences. This consistency is perhaps the deepest message. The speed of light is not a rule for the young universe. It is a rule for all eras, from the first photons to the last observers. And that means the limit is not just about speed, it is about destiny. The destiny of information, connection, and shared reality. And that destiny is already unfolding. Yet even in this distant future, one mystery remains. Why does the universe choose to expand at all? Expansion is not something the universe decided to do, it is something that follows from its initial conditions and its laws. When space-time came into existence, it was not static, it was already stretching. This stretching is not driven by motion within space, but by the dynamics of space itself. Gravity, energy, and geometry are intertwined. The equations of space-time do not favor stillness. They describe how space evolves in response to what it contains. Matter and energy curve space-time. That curvature determines how space-time expands or contracts. In the early universe, density was extreme. Expansion began rapidly, driven by the enormous energy present. As the universe grew, density dropped and expansion slowed. For a time, gravity tried to pull everything back together. But another component, dark energy, altered the balance. Dark energy does not cluster. It does not dilute in the same way as matter. As space expands, dark energy remains. Its effect becomes stronger as the universe grows emptier. This causes expansion to accelerate. The limit of light speed does not oppose this acceleration. It shapes its consequences. Expansion can accelerate forever without violating local rules. The universe can stretch faster and faster, while nothing locally outruns light. This creates horizons that shrink in influence even as space grows. The future becomes increasingly fragmented. Expansion is therefore not in conflict with the speed limit. It is its partner. One defines how fast influence can travel. The other defines how distances themselves evolve. Together, they sculpt cosmic history. The universe expands because its equations allow and require it. There is no external space into which it expands. Space is not moving through something else. It is redefining distance internally. This is difficult to visualize because human intuition expects motion through a background, but space-time is the background. Its change does not need a reference. This expansion has no edge. Every point sees others receding. There is no center. This uniformity is another consequence of the same underlying laws. The universe does not privilege locations or directions. The speed limit applies equally everywhere. Expansion applies equally everywhere. This symmetry is not accidental. It reflects the simplicity of the fundamental rules. From these simple rules, complex behavior emerges. Galaxies form, horizons appear, isolation grows. Yet the equations remain compact. This elegance suggests that the universe is not chaotic at its core. It is constrained, structured, and consistent. The speed limit is one expression of that consistency. Expansion is another. Neither can be removed without breaking the framework. The universe chooses neither freedom nor restriction. It chooses coherence. That coherence produces both connection and separation, both possibility and limitation. Understanding this reframes the human desire to transcend limits. Limits are not enemies. They are the shape of the world. To ask why the universe expands is to ask why its equations have the form they do. That question leads beyond physics into deeper territory. It touches on the origin of laws themselves. Why these rules and not others? Why this structure instead of chaos? Physics can describe how expansion works. It cannot yet explain why the laws are what they are. The speed limit, expansion, and geometry are given. They define the game. Everything else is a consequence. And within those consequences lies every story that can ever be told, including the one asking these questions. But there is one more layer still, because even within these fixed laws, something surprising remains. The limit that governs everything may not be about light at all.